10x your service design offering with Smaply. Take 20% off any order with This Is HCD 20 off. Let's superpower you and your design team's potential. Sign up at smaply.app. Enjoy the episode from your friends at Smaply, helping support This Is HCD podcast.
Welcome to Worldwide Waste, a podcast about how digital is killing the planet and what to do about it. Is technology a good thing? That was my first question for Dr. Sharon Richardson, who is a senior scientist and lecturer in geocomputation at the University of Zurich, where she applies data-intensive methods to improve understanding of and assist in human societal and environmental challenges. Sharon also has a keen interest in exploring the potential and limits of AI in real-world decisions.
Yeah, it's an interesting one though, isn't it? Because I think there's a statistic, and this could be completely wrong, I'd need to check it afterwards. But, if we want to revert back to, say, hunter-gatherer era, then we can only sustain around about, 250,000 people on the planet in that lifestyle. Technology has enabled us to grow as a population. And that's an interesting debate to be had. Is that a good thing or not? Because generally, well, I'm here, and I wouldn't be if we'd said no to that. So I think technology ultimately is a good thing. It's enabled us to get to the billions, which we otherwise would not be possible on this planet. And the frustration is that used well, there shouldn't be the massive downsides that we're currently seeing. So it's not. We can't just, it's a little bit like the example of electricity. You can use electricity to make toast or to kill people. It's just, do we then say, oh, well, electricity is too dangerous, we should never have invented it? And of course, that would not be particularly sensible. So it's how we end up using these things. There was a great book I read a few years ago now, Physics for Future Presidents, and it talked through kinds of scenarios relating to physics that a future president should think about. And so there's nuclear, climate, all the different scenarios. But there was a statistic in it. And again, I let's come back off the top of my head so I can look it up afterwards to confirm it. But it went through the fact that every decade going forward, the actual energy savings on technology were enabling us to do more. And that if we continued the progress of the last 100 years, by the end of this century, the planet could support a population of 9 to 11 billion, all living at the European standard of living, if we followed that progressive track. And one of the examples given was quite a simple one, which was if we still all use the types of refrigerator that were around in the 1970s, I think in America alone, it would require something like an additional 50 gigawatt power plants to run the refrigerators if they were still using 1970s technology refrigerators instead of the modern ones, which are much, much more efficient. And so there were these scenarios where you thought, wow, that makes sense. I suppose what we didn't envisage is technology generating a new form of demand that in itself is creating a huge energy demand. But even if all the data centers become, say, completely carbon neutral, which the big tech platforms are all claiming they will, it's all the people then using those data centers as well. I mean, how many more TikTok videos do we need? How many can be classed as, say, art versus waste? Because there's an energy cost every single one that we upload.
I find it hard to understand the data centers, saying that they're going to be carbon neutral, because are they not counting the data servers themselves, each of which create at least a ton of CO2 to be manufactured? I find a lot of these accounting things, how these entities are accounting for being neutral as being strange, that they kind of don't account for the actual devices. They just talk about their renewable electricity, but most of the waste is actually in the device itself. It's in the server or the computer or the smartphone that is connected to these data centers. So it's a kind of a strange accounting model they have when they talk about being carbon neutral.
No, absolutely. What happens, for example, if one of the large enterprise players, their next big client says, well, we're going to spend X million a year, hosting things on your data center, but we're not pursuing that carbon neutrality, and we're going to be using these things, this equipment that will cause a massive carbon cost. Would the platform say, well, we're not going to have you as a customer? That would be an interesting dilemma to see play out.
When I was researching my book Worldwide Waste, one of the stats that I kept coming across in the kind of different variations was that 90% of data is not used either 3 months after it's created, or it's never used to begin with. That we have, these engines of producing data, and that in the vast majority of situations, we really, it's not good, like a huge amount of it is just of no value to begin with. So it never gets used. And then some of it that may well be useful, well, we still don't have great capacity to use it. But this sense of, that our capacity to create data vastly outpaces our capacity to use it. What would your experience be in that?
I think you could use a simple example that most people can relate to, is that it doesn't happen so much these days, although some people still do, but there used to be a phase where you would create a careful set of subfolders in your inbox to file away your emails should you ever need to read them again. And I would challenge how many people ever so much as looked inside one of those folders ever again. How many times did anyone go back over an old email from 6 months ago, let alone a year ago? I would wager very, very few people. And so, yes, this is a huge challenge, is that much of the data being generated has minimal value, but it's knowing which bits are going to get used. That's the challenge. I don't know off the top of my head what the solution is as to whether or not, how do you create some kind of tax or cost to make people more careful about what data does get captured and stored because of its cost compared to its potential value.
That's a really interesting concept. I've been thinking as well about that we will need at some stage a data tax in some way, because there's such an explosion of data. I was talking to a physicist who was saying that there's a theory, not everyone agrees with it and it's not been totally proven, but that actually data has a weight, a physical weight. It's a microscopic weight, but that it has a weight independent of the weight of the hard disk or whatever that it's stored on. And that this physicist estimates that within maybe 3, 5, or 600 years, depending on the growth of data, that this weight will become really evident and will become, very significant in the Earth's mass, because we are creating such unbelievable volumes of data. And he was saying we ain't seen nothing yet with Internet of Things. It's going to explode in exponential values, so that at some stage quite soon, data will really begin to stress organizations and stress societies in the massive volumes that it's being created. Is that something you see coming, or do you think those fears are unnecessary, or what do you think?
I think it's fascinating what he's proposing, that there's some kind of additional actual weight to information beyond, because we often talk about it where you can say it's expressed in physical form the minute you print it out on a piece of paper, or even arguably if it's visible on a computer screen. And certainly when it's stored on a hard drive, there's a physical artifact now involved. And we've both been around the digital for a similar period of time. We've been through that process of working with organisations transitioning from paper to digital, where one of the big arguments is the sheer reduction of physical storage space required is a significant cost saving. So to then say, well, things keep getting smaller and smaller. So you can argue dropping from paper down to digital was a massive reduction. But yes, if that digital then keeps exploding, will it then eventually fill the same amount of space, but with, realms more information than was possible with the physical in paper form.
See, I had this image that a lot of AI, we train it in McDonald's. We train it with very poor quality data, but not alone. It's not. It's almost like the dump yard in McDonald's. It's like the bins we feed. If we're feeding a lot of low level data that we don't know because we didn't clean up the data lake, or there's some, and we don't know a lot of times whether it's good or bad, but we're just feeding these massive quantities of data to AI. Isn't there a danger that AI, because there is this a kind of independent, oftentimes we're not quite sure exactly what's happening in these machines or exactly how it's interpreting, but that if we feed AI junk, we get a kind of a junk AI in the sense, or a kind of a hungry AI, or a type of AI models that actually demand huge quantities of data going forward as well. We don't kind of make them clean living AI. And this may sound like crazy talk, the sense of, that they're not designed to live off as little data as possible. They're designed to demand as much data as possible, and that creates energy inefficient designs.
Yeah, this is where I actually think we will have a breakthrough where our design of AI changes fundamentally in the not too distant future. I think the most advanced AIs we've reached to at the moment are ones that use deep learning and deep reinforcement learning. And they're either fed massive amounts of data, or they run massive amounts of simulations as they learn scenarios from what are often quite simple rules to begin with that become quite complex scenarios. And we've seen that with the various incarnations of alphas that Google's produced. But at the moment, the general approach has been, more data is better. So feed it, it's like if you're training a computer vision algorithm, feed it as many images as you can give it. And it'll ultimately outperform a human, which has been proven. I think it was 2014 when a computer vision algorithm first outperformed humans at object detection in images. But we're still, sort of simultaneously as we're developing on the computer science front, we're learning more and more about how the brain works too. And the current incarnations of algorithms are very much based around neural networks. I think that's no surprise to anybody. But we are starting to have other breakthroughs in terms of, well, how do we process information? Because, if I ask you a question, and you answer it, I doubt you'll have a conscious awareness that you went and trained a classifier on your vast memory bank of previous experiences of raw data, and then from that classifier came up with a prediction. Instead, you quickly sort of grasped at abstract concepts that you just know, that you've learned through life, and then probably blended that with your most recent experiences. And I think that may be the kinds of breakthroughs we'll see going forward, where an AI might have its initial training on quite a large data set, but I don't think it will keep training on new data, but smaller data. And I think it will develop better parameters and algorithms that start to have abstract concepts rather than requiring a huge amount of raw data each time to make a change. I mean, it's a given example. It's some of the DeepMind breakthroughs they had with playing computer games. I think it was the catch the flag scenario. Your computer performed brilliantly, but then if you make one change to the game, change a rule or change a structure, you've got to go right way back to the start and retrain the classifier all over again. Whereas a human will just look, yeah, okay, I can kind of envisage what that impact that change is going to have and adapt. At the moment, our AIs don't adapt very well. And I think that's the breakthrough we'll have, where we'll see a fundamentally different approach to the amount of data. So I think it'll become much less greedy, but much more contextual. So what's the current data in this scenario, as opposed to some archive that reflects some past that may or may not be appropriate to learn from.
Well, that would be a major improvement. Sharon, do you see in conversations that awareness among AI researchers that they are gluttonous for energy, like that their systems in a climate crisis are incredibly they're like massive gas guzzling Hummers, and that this is not exactly scientific models that we should be and approaches developing when we are worried that there may not be a planet that is livable for our children and their grandchildren. Is the AI community aware that its habits are, and that its current scientific practices are more like the oil industry than than a sustainable industry?
Yeah, I don't think that phrase "data is the new oil" helps on that front whatsoever. I think there are people within the community that are aware of it and concerned, but I think there's a lot of different aspects that are raising concerns at the moment, because obviously ethics is a very, very big concern at the moment. There's much more awareness now of the bias in AI algorithms, and the reality that an awful lot of them are merely reflecting the cultural biases that have existed in society for years, decades, even centuries. And we're seeing that reflected back at us when we build a machine off that archived data set. So there's a huge community now really looking at AI ethics, and should we have some kind of equivalent of the medical Hippocratic oath, when building a new AI, should there be constraints, or because at the moment there are none. I was writing an article recently, and I don't know if you remember, back into sort of around about 2000, 2001, there was the Enron scandal, which brought down both Enron and their auditors at the time for being fraudulent, and it led to the Sarbanes-Oxley Act to try and prevent it from happening again. We haven't got anything yet like that to constrain AI, despite the numerous examples of abuses that we're seeing within the criminal sector, for example, within benefits. We saw it with the A-level algorithms fiasco last year, and the untold mental health issues that may have caused for some poor students who were completely unfairly judged by an algorithm that was known to have insufficient data to produce a reliable result. At the moment, there are no checks and balances. There's no cause for redress. There's a whole host of areas of AI that needs tackling at the moment.
Yeah, and you just reminded me there, it wasn't AI, but the post office scandal in the
Yeah,
UK.
that's another one. Absolutely. It's perhaps even worse because it's so simple and distressing. But the fact that there was a fault in the software, so it was misreporting. And despite numerous people having no prior history of any criminal activity, being considered upstanding citizens, it didn't matter. It's like, well, the computer says no. The computer says this, and we're going to trust the computer more than character references, testimonials. And they had no cause for redress, and it's taken years to now realise that they were all innocent. And some people have died. Some have been ostracised from their communities. There've been divorces. It's horrific that it's taken this long to finally acknowledge that it was a fault in the computer system.
Yeah, it's amazing. Yeah, and I think, we seem to have this inbuilt, part of our DNA to look for new gods. And it feels in many ways like technology is the new god at the moment. Is the hip Jesus? That the computer says, and therefore it must be right in the process, that we just externalize this sense of there's this higher thing that has the understanding, and that we must follow it, and yet as you say, it's just a malfunctioning computer program, and that's just at such a base. That's wasn't an AI system, but when you consider the levels, I remember early ones and particularly, minorities, and particularly gender. And I saw early AI systems that recommended that women were just having a panic attack, but that men were having a heart attack, because, there was 100 years of data of male chauvinist doctors misdiagnosing women when they'd come in to visit them, saying, you're just panic, there's nothing. And that was the records of misdiagnosis that was fed to the AI, and the AI just became a male chauvinist pig because that was the data.
Well, I think the Microsoft Tay bot experiment is the current favourite one to bring up to demonstrate that an AI will typically just reflect society back at us, and we might not like what we see. Because you must remember that when Microsoft released the chatbot onto Twitter, and it started off being very friendly, and I think it was hours, it turned into a foul-mouthed, abusist, sexist, racist, homophobic, you name it. If it could insult someone, it would. So absolutely. I think we're a little bit in thrall of data sometimes, and I say that as somebody who works with data all the time. And when somebody gives me an opinion, I am prone to say, show me the data on that, because opinions are easily formed sometimes on the scantest of evidence. But that said, my favourite phrase at the moment is this idea that an over-reliance on data can produce just as flawed a decision as an over-reliance on beliefs. It's the real world is messy. It's we've created an artificial environment from ourselves. The minute we started building things, human nature and our social organizations, they're messy, ambiguous, sometimes chaotic environments. And at the moment, we're expecting clean, precise answers from AI that's not really fitting with reality, and so it can be just as wrong as asking somebody to have based on their belief, what do they think happened.
And how do we, solve that? Because, I've been spent years, in web design and all, database decision making, and let's judge how this page works based on A/B testing. And I thought that was the holy grail, and that, and as you say, it's a lot more messy. And one of the things that I've noticed in being involved since the mid-90s in designing really big websites. Like I've worked for Microsoft a lot and a lot of the technology companies and over the years, and building really big websites, is that the skills, what are sometimes called information architecture, are actually in decline. That less people are skilled at, and there's less interest in organizing information and coming up with classifications and structures than, in my experience, than there ever has been. And part of the reason is, Google will sort that out. Why do I need a set of folders? I'll just search for it or whatever. So as data explodes, the actual essential skills to structure and organize it are actually in decline. Am I crazy, or are you seeing the opposite of that? But that's what I'm seeing. Information architecture skills in decline during a period when they have never been more needed.
No, I'm not going to disagree with you there. I'd add to it as well. I think data presentation is woefully under-researched and underappreciated at the moment too. We're presenting outcomes from increasingly complex algorithms, and the standard criticism for somebody who perhaps doesn't understand what's coming out from the algorithm is, we need to improve data literacy. We need to improve digital skills in people. And I don't disagree. That's something that, will be beneficial for everyone. But there's also a responsibility on those designing the systems, that their systems are understandable. I think we need a massive investment in human-computer interaction and user interface design too. As we start to have medical apps on our phones. There was an example actually given by Professor Yvonne Rogers of University College London at a talk just last month, and she was talking about this exact challenge, saying, well, what if you've got an app that you take a picture of your skin and then it diagnoses a mole and it says it's cancerous? What should it tell you? Should it just say, we think it's cancerous, contact a doctor? Should it tell you, well, it's 20% likely, or we think it's 80% likely that it's cancerous? Does these differences matter to the person? There's been very little said about how the results are presented from these algorithms. And I think if you look at a lot of the headline cases that we've seen, such as the poor use of AI, well, it's simpler than an AI really, but the use of the compass algorithm in the American criminal justice system, where it was simply your colour would determine whether or not you were likely to commit further crime. I mean, it was just a shocking failure. But that's partly because the information was presented poorly. Nobody thought about how do we present the results of what is a complex series of steps that then gets to this one number. What does that one number be? And should it actually be one number? Or should it actually be a series of a criteria with some kind of explanation? Now, I work a lot with spatial analysis now and maps. And Gerry and I saw a great talk once by, I think it's Albert Cairo, who does a lot of work in map visualization, saying, well, maybe we should make the maps harder to read. Maybe we should require people to work a little bit so they don't just jump to a quick conclusion. They need to dig a little bit deeper into the visualization. So I think data presentation, as well as its organization, they're skills that we desperately need more of as we rely more and more on these systems.
It's a great point that Professor said. Sometimes you need to make things harder. Is it always good, to make it easy to buy so much stuff, or to buy, there's a huge problem in e-commerce about e-commerce returns, that, so it's very easy to buy loads of clothes, but it's not easy to know, are they going to fit you, or should you buy, and should you get them delivered, in 24 hours, or in 3 days, but 3 days would probably be better for the planet because it's a more sustainable delivery medium. So all these, making it easy for you to get convenience and quick, sometimes you do need to make it hard, or at least make people think more. So these are big design challenges as well. And yes, a lot of times we don't really delve into them enough.
No, absolutely. A book that was quite popular, I think, because he's been very vocal on COVID too. I think it's called The Art of Statistics, but it's by David Spielhalter, who studies risk at Cambridge, I think. And he talks about the fact that, because people are becoming much more aware of Bayesian inference and its role in decisions, and I'm very much in favour of Bayesian modelling over frequentist statistics, because it effectively enables you to update your beliefs. It tries to bring in this combination of having both data and beliefs, and how do we resolve them. But it's quite fascinating in his book, the fact that this approach isn't allowed in courts because it's considered to have sort of ambiguity, and that's not a good thing. We want clarity, we want a clear decision. And so maybe we just, as as a species, we need to embrace ambiguity a bit more, I think. We need to find ways to understand there isn't one single answer in so many different scenarios, and to be better at understanding the different trade-offs or the different consequences that each possible outcome is going to produce, and accept that we're going to pick one of them, but we're going to pick one knowing that it might be optimal in some ways, but it's going to be suboptimal in other ways, and we need to have thought about what that means. And that can, then cover so many different scenarios, including the concerns around ethics, bias, climate costs, and so forth. At the moment, I don't think we do that. We just look at one possible outcome.
I was in touch with some Dutch researchers who were researching self-driving cars, and they're going over their numbers again and again because they can't believe them. But the current numbers that they have, and they've cross-checked them multiple times at this stage, are showing that if the Dutch fleet, transferred over right now or within the next couple of years to self-driving cars, so the entire is not physically possible, but let's say it was possible, and that in the way that each of these cars that are throwing off, these current models are throwing off like a couple of gigabyte a second of data, they're saying that basically it would demand like 10, 20, 30 times the total electricity supply of the Netherlands to run that fleet. That that the solution, some of the solutions to save the planet, so to speak, because self-driving cars are saying, we're going to drive more efficiently, and there'll be less crashes, and there'll be better consumption of electricity, etc., etc. But the actual data required to keep them on the road, and all the infrastructure around that data, is vastly greater than any efficiencies gained in driving more efficiently. So some of the solutions I'm seeing coming out of the technological space are more likely to kill the planet before it saves the planet. But what sort of ones might help us, say, to walk more or get on the bicycle more? Because I think we don't need self-driving cars. We need more bicycles. We need more 15-minute cities, like in Paris, what they're trying to do. How can data help, in those areas where we can really get the win-win of, healthy people bicycling and data helping them to bicycle more, rather than, these other areas which I'm increasingly seeing are not necessarily going to help at all. They may be wonderful technical solutions, but they may create far more pollution as a side effect than the solution that they actually create.
Yeah, that's a big one. To answer. I mean, the thing with autonomous vehicles is, in particular, I think, is it's a little bit like the flying cars of the 1950s, and we still haven't got those. I think a lot of people are dialing back on their predictions as to when we'll have such things on the roads because of so many different complexities and the energy cost of running them being one of. So it's a big topic in its own right to answer that one, because a lot of it's going to ultimately come down to leadership visions. What kind of world do we want to see in the future? We're seeing a huge pushback against globalization at the moment. What's that going to mean? We could head off into some very, very big topics here, possibly beyond the realms that either of us can answer. So, it is ultimately going to come down to some tough decisions are going to get made. I mean, in my research of cities, when I did a Smart Cities Masters a few years ago now, which led into the PhD, and overwhelmingly the best cities were the small ones. Time everywhere, it wasn't the big metropolis. It was generally the smaller ones. So, like in the UK, it's like Edinburgh, Winchester, anywhere with a cathedral that's quite small but still gets city status. And the same in America, So areas in the cities in Silicon Valley compared to the huge metropolis, they're generally people are happier, healthier, and that works. But we're back to a scaling problem in terms of population size as well. The general assumption has been, based on the numbers, is we need the big cities to cope with the big populations. I had a stat on my blog a few years ago, and I haven't checked whether how much it's changed, but it's still the fact that we now know over half the population lives in cities, and over half of that population lives in slums. And frankly, they are not concerned about electric vehicles or autonomous vehicles or AI or anything. They're surviving. So this is where it becomes a challenge. Which challenge are we trying to solve here? So I will be very interested to see when that study comes through. There's a lot of research getting specifically into vehicles. What will be the impact if we did have autonomous vehicles? Because it's not just the cost of the data generation and running them, but there's the other models show that they would produce more trips, not less. Or fewer, sorry, using the correct terminology. There's an argument around at the moment, 40% of land space in cities, in America at least, I think, is car parks. So would it suddenly release lots and lots of land for redevelopment? And then it's like, well, actually, no, we'd end up with more of these. So unless we get the smart car parking where we can sink them under the ground or have skyscraper car parks and what have you, then we've got to put them somewhere. So there's so many different challenges that we're a long, long way off solving. Just getting to the point where we've got one of them working on the roads without killing people is a good start point.
Yeah, and what do you think of the idea? Maybe the best of both worlds. What Paris is really trying to drive, the 15-minute city in a kind of like multiple cities in a city. That everything is within 15 minutes walk that or 15-minute cycle or stuff in the process is that. And I wonder how, data could help that type of, is it a ways of that the greengrocer or the, I think some people are looking at the return of the milk man or woman, so to speak, in the process, but in a different concept, that there's a local provider with cargo bikes, but a kind of bringing all sorts of materials, vegetables and stuff like on a constant, a kind of system or in a very localized area. And that would probably require quite a bit of coordination, so to speak, in an app, or getting everything freshly around an area. I wonder, is there ways where we could have small data rather than big data, or that because data is still so, it's how we have become, if we do it right, it makes things work so much better. But maybe it's small data in 15-minute cities ideas, around helping people to walk more, or cycle more, or cargo bikes rather than self-driving cars.
Yeah, I'm quite a fan of the 50-minute city concept to start getting thinking, because it's taking more of a design thinking approach to cities too, which, well, that's always been there, but throughout the 20th century, obviously the car has dominated an awful lot of the approaches taken. So you saw a real shift to zoning, where you've got your suburbs where everyone lives, and then you've got your central business district, and you've got a big retail centre district outside, on the outskirts of towns and so forth. Everything involved requiring a car. And so in terms of, there's another vision that's starting to grow in popularity, the 20-minute neighbourhood too, which is of a similar ilk, which is do we get back to this? It's actually just going back to how things used to be happening. If you look at how London grew organically, it's actually a collection of villages that just joined up over time, and you still see that in the naming conventions and the different high streets in different pockets of London. So London as a city is quite a good example of lots of villages joining up into one giant city, as opposed to the sort of huge design from day one city where it is just a massive grid-based metropolis. So, yeah, data will become essential to those sorts of scenarios, because we're looking at potentially much more hyper-local distributed systems. There's a big push for, should we see more urban farming in these scenarios? Because farming and agriculture is causing a huge impact on the environment and the sustainability, the ability of the planet to sustain us, at least. So if you're going to have much more urban farming, it's local, but it's got to be distributed very, very quickly to avoid waste. So absolutely, there's going to be a role for data in those types of scenarios. But it is going to require much more of a sort of holistic systems thinking approach to connect all these ideas together into the kind of future life we want to see.
I saw a fascinating study there a number of years ago in China, where they increased crop production by something like 5 or 7%, which is very substantial, like over a 20-year period. And they did it with practically no new technology, but basically creating big networks of farmers and policymakers. And so they'd say, oh, we planted it. They started multiple experiments of crop rotation, planting, seed depth, etc., and they just tested different soils and different planting, etc. But they fed all the information around to government people, to local farmers, etc., using the web essentially. So they didn't buy any new tractors or stuff, but the sharing of the data and what was working and what was not working really reduced pesticides, reduced fertilizer, and increased crop production. And I think, in the cities, some will have growing in undergrounds and infrared, etc. I think the sharing of what's working, what's growing, what's not growing, with 10,000 farmers, feeding into a central database, here's what I did today and here's how it grew. We can learn from each other. We don't need, this is where I think data is so exciting, isn't it? That can really help better crops, cleaner developed, more locally delivered, just in time. So this is where data could really help the planet.
No, absolutely. We've done well not to mention COVID really and get this far through the conversation. But COVID and SARS before it are good examples too, with having computational power and data, enabling scientists to work, globally to come up with solutions that previously took us decades or at least years, or, to bring that cycle down from decades to years, years to months, months to days, days even to hours. This is some of the possibilities that we see now, where it's phenomenally good thing to have access to the data.
One thing that unfortunately didn't happen is that very early on, certainly in Asia, the scientific consensus was that COVID was airborne. And yet the Western societies in particular were very, very slow to accept that data, that, which had a massive impact on the spread of the virus, versus the conventional wisdom that wash your hands and it's going to be spread through surfaces. Yet the data was there very early that it was airborne. And yet we weren't able to, as organizations or societies or medical establishments, accept that data.
Yeah, I think this was one of the interesting examples, again, with coming back to what we were talking about earlier, with data and beliefs sort of having a bit of friction. Because if I understand correctly, and again, I could be wrong here, a lot of the early modelling was the belief that it would behave like flu. And so it was modelled like flu. And so hence the focus was very much more on droplet spread and fomites off surfaces, which is the general consensus of how flu spreads. And I think there was such a strong belief on that model that it almost override seeing what the data was telling them at the time, and because we've seen these sorts of examples before, where if what if you've got a certain strong belief that, well, this is the way things are, it's very difficult, even when you've got data, to push back on that kind of belief.
Yeah, and isn't that the conundrum as well? We need the belief and we need the data, because if we just believe in the data, we can make almost worse decisions than if we just believe in belief.
Absolutely. This is one of the big, it's back to this idea that we need these systems of redress, of ways of testing, is there something missing here? What's the data we don't have? It's like that classic example everyone goes back to, the figuring out what was causing the weaknesses in planes returning from World War II. And it's, don't look at where the bullet holes are, look at where the bullet holes aren't, because they're the planes that didn't come back. And we still struggle with that. There was the great example with DNA. Once DNA testing became a thing, it became such a certainty that, well, if your DNA showed up in a crime scene, you were there because your DNA is there. So how could you not have been there? And yet there's countless examples now where it's been proven afterwards, and often after people have spent some time in prison, that there was cross-contamination. And that they never. And there was the one example of a gentleman who had an absolute cast iron alibi. He was in hospital, but his DNA was detected at a crime scene, and he spent 6 months in prison before they finally got to the bottom of it, which was he was transported in the same ambulance, and somehow some part of his DNA ended up under the fingernails of the victim at the crime scene. So it transferred via the paramedic that collected the samples. You wouldn't think that was possible, but it happened, but it took 6 months, despite the fact this man had an alibi with ample witnesses, because he was in a hospital at the time of the crime, and yet he was still arrested because he failed the DNA test. Such was the belief in the absoluteness, accuracy of the DNA testing, that they didn't think about potential for contamination. And I think this is where our decision maturity needs to improve. We need to be able to stop ourselves and say, okay, we've got a strong belief and we've got quite a bank of evidence here, but we've got some data here, or we've got a blind spot and we're not addressing it.
If you're interested in these sorts of ideas, please check out my book, Worldwide Waste, at gerrymcgovern.com. To hear other interesting podcasts, please visit thisishcd.com.